Hello everyone, welcome to the post-contest discussion of the Codeforces Educational Round 171. This is TLE Eliminators and I am Abhinav. Let's get started with the first problem. So in the first problem, we are given that you are given a coordinate plane and three integers x, y, and k. Find two line segments AB and CD such that the coordinates of points A, B, C, and D are integers and this the x coordinate lies in the range from 0 to x, y coordinate lies in the range from 0 to y. The length of segment AB is at least k, length of segment CD is at least k. The segments AB and CD are perpendicular. Okay, and like if you draw lines through AB and CD, they would cross at right angles. That's what it means by perpendicular. It's not necessary that the segments intersect. Okay, so basically you are just given three integers x, y, and k as input. Okay, so x and y just denotes the maximum limit where my x coordinate can go, the maximum limit where my y coordinate can go. Now we just need to select in the in the coordinate axis from the x coordinate would go from the range of 0 to x, the y coordinate would go from the range of 0 to y. So in that block we need to find two segments, okay, two line segments AB and CD, says that the two line segments are perpendicular to each other and the length of both the segments is at least k. Okay, that's what we need to find. And it's also given that the values x, y, and k are chosen in such a way that the answer always exists. So we can always find such two segments which are perpendicular of length at least k inside the given range. Okay, that is also given to us. Now we just need to print our answer for the given x, y, and k. Okay, so like for the first case, you can see when x, y, and k was 1, 1, and 1. Okay, my answer was, okay, we needed to print the coordinate of A, coordinate of B. Okay, so first the coordinate of line segment AB. So x coordinate of A, y coordinate of A, x coordinate of B, y coordinate of B. Like this we need to print. Okay. Then x coordinate of C, y coordinate of C, x coordinate of D, y coordinate of D. Okay, so you can see for the first test case, the answer is given as this. Okay, so 0, 0 denotes the coordinate of A, 1, 0 denotes the coordinate of B. Okay, so A is at 0, 0, you can see, and B is at 1, 0. Okay, so this is our line segment AB, and coordinate of C is 0, 0. So C is also at 0, 0, and D is 0, 1. So D is here 0, 1. So CD is this line segment. Okay, so you can see like in this case, we had this AB as one line segment and CD as another line segment. Their length is 1 and 1. So K was given as 1. So length is greater than equal to 1. That is okay. And both these line segment, we can see they are perpendicular to each other. So that is also okay. So this is a valid answer for us. Okay. For the first test case, this was a valid answer. Okay, so likewise, we just need to print the valid answers for, like you can see for the next test case where x and y was 3 and 4. So our range was basically in the coordinate axis. We can go, x can go up till 3 and y can go up till 4. Okay, so we needed to find a point in this range from 3 to 4. In this, we needed to find two line segments which are perpendicular and of length at least k, where k is given as 1. So at least one length segments we needed to find. So the answer given here was this CD and this AB. Its length was 1, its length was 2. So both 1 and 2 are greater than equal to 1. And you can see that these both are perpendicular to each other. Okay, so this was one pause. So we can just print any answer. There would be multiple answers. So there can be multiple answers. Just print any of them. Okay, so basically what would you do here? Okay, you can see like we are given a x, y, and k. Okay, so it means in the coordinate axis, we can, so in the coordinate axis, we have two lines. This is our point 0, comma 0. Okay, so x would go up till this capital X, y would go up till this capital Y. Okay, so in this range, basically, you can see in this range, we need to find two line segments of length at least k, and they are perpendicular to each other. Okay, and we are also given that the answer would always exist. So what you can do here is, what is the like you need to find two segments which are perpendicular. Okay, so one thing you could do is take a line segment this and take a line segment this. These both would be perpendicular. But you may see that this k may be greater than this length. Okay, so if we are taking something in the slanting, then we can obtain more length. Okay, so let's say, like, let's suppose x is given as 3, y is given as 3, and k is given as 4. Okay, so in that case, if you want to take okay, so if this is 3 and this is 3, you want to take a length of 4, then you cannot take this 3. You would have to take something in the uh, something slanting. That way you can take more length. Okay, so if you take like this, okay, let's suppose x was 3 and y was 3, then you can take this line, this diagonal line. Okay, so its length would be like 3 square plus 3 square. It would be 3 square plus 3 square under root. So this would be about under root 18, which would be greater than 4. Okay, so this length would be greater than 4. So this would be valid. And we need to take one more line which is perpendicular to it. So for that, we can take this other diagonal. So both these diagonals would be perpendicular. So that way we can take these two line segments, which would have length greater than 4, and it would satisfy our conditions. Okay. So one way was just take this segment and this segment, but here the problem was if my k is greater than y or greater than x, then we cannot. But what is the maximum length we can have in this in any rectangle? Is the diagonal. We cannot have anything more than the diagonal. Okay. So if we are taking the diagonal and we want its perpendicular also to exist. Okay, so now we know for sure that k would be less than equal to the length of the diagonal. If k is given more than the length of the diagonal, it means answer would not exist. So it's given that answer always exists. It means that k is less than equal to length of diagonal. That is for sure. Okay. Now, also, what if x was 3 and y was 4? Okay, let's suppose x was 3 and y was 3, x was 4. Okay, if this was the case, this was 4, then what would be this diagonal? Okay, so this who is more length, this is less length. So this diagonal would be 3 square plus 4 square. It would become 5, you know. Okay, so 3 square plus 4 square. This length of the diagonal would become 5. But if we want to take a perpendicular to that, so if we have this line, okay, this length is more, this length is less. If we take the other diagonal, it won't be perpendicular to it. So anything perpendicular to that would be something like this. Okay, like if you imagine, if one of the length is more and one of the length is less, and we are taking this. Okay, so on taking the other diagonal, this won't be perpendicular. So anything perpendicular to that, if we are taking, so it would, like you can see, if this is the line and we are taking something perpendicular to that, it would have a greater, if it has a greater width, then the perpendicular line would have a greater length. So basically, you can see that for where x and y are not equal, then this we cannot take this diagonal because we won't be able to have a perpendicular to that. And it's given that answer always exists. So it means this case would not be given to it. K for x equal to 3, y equal to 4. Okay, for this case, x equal to 3, y equal to 4, we won't have k equal to 5. This case would not be given to us. This we can prove that because answer would not exist in this case. Okay, if we take this diagonal and that diagonal, they won't be perpendicular. So for answer to exist, what is the maximum k that could have been given to us? It would be if we take a square, the diagonal of a square. Whenever we take the diagonal of a square, to that we can draw a perpendicular. We can take the other diagonal, it would be perpendicular. So only for a square, the other diagonal would be perpendicular. So basically, the maximum k that could be given to us is going to be the maximum diagonal of square that we can get. What is the maximum diagonal of square is, what is the maximum square that you can get is minimum of both of these. So if 4 and 3, if we are a rectangle of 4 cross 3, the maximum square would be 3 cross 3. Okay. So you can just assume that your x and y both are equal to the minimum of both. If you are given 4 and 3, you can assume that x is just 3, minimum of both of them. If you can make something in this 3 cross 3 square only, if this is 3, if you can make a diagonal in 3 cross 3 square only, its perpendicular would exist. Okay. So basically, this was like a proof of that why we are what we are doing is, instead of uh, considering as x and y, if they are different, just take both of them as minimum of x and y. Okay, so consider this square, and in that just take both the diagonals of the square. That is the maximum length segment you can get, which would have a perpendicular to that. Okay, and we want to answer any segment which is greater than equal to k. So if we take the maximum segment, that would be greater than equal to any k that we are given. So what I would do is directly just print this. Okay, whatever we are given. Okay, we are given some x, we are given some y. Take the minimum of x and y. Let's say the minimum of x and y is n. Okay, so if x was greater, this would be n. Okay, here something, it would be n. And for this square, take this diagonal and take this diagonal. Okay, just take both these diagonal. So this would be our point A, this would be our point B. You can say this is our point C, this is our point D. Okay, so just print the coordinate of A would be 0, 0. B would be n comma 0. C would be uh, uh, B would be n comma n, sorry. Okay, this point would be n comma n. C would be n comma 0. D would be 0 comma n. Okay, so in our final answer, we would just print coordinate of A 0, 0. Then coordinate of B is n n. Coordinate of C is n 0. Coordinate of D is 0 n. Okay, so we can just print this as our final answer, where n is minimum of x comma y. Okay, so I hope you understood. This would be just our final answer. Calculate n as minimum of x, y, and just print this. Okay, is that clear to you? Okay, if there's any confusion, why we took minimum of x and y was because if you have like x equal to 3 and y equal to 4, the 3 cross 3 square would be the greatest square you can get. And for a square only, we can have diagonals perpendicular to each other. So if you take anything, if you consider a rectangle of 3 cross 4 and take that diagonal, you won't be able to obtain a perpendicular to that. So that case would not be given to us, that we are sure, if in the question is given that answer always exists. Okay, so I hope you understood this. So our code would be very simple. N would be the minimum of x and y, and we would just print 0 space 0 space n space n. Okay, so first would be 0, 0 space n, and then we would have 0 space n. Okay, you write n0 and 0n, or you can also write it as 0n and n0. Like both is okay. You can take this as C and this as D. There is no problem. Okay, so you can print this also or this also. Okay, I have printed this in my code, 0n space n0. Okay, so 0 space n space n space 0. Okay, so this and this are printed and we are done. Okay, this was only our code. I hope you understood. If there's any doubt in problem A, you can ask, or we'll move to the next problem. Okay. Okay, let's move to the next problem now, which is problem B. So you are given a strip divided into cells, numbered from left to right, from 0 to 10 to the power 18. Initially, all cells are white. You can perform the following operation. Choose two white cells, I and J, such that I is not equal to J, and the distance between I and J is less than equal to K, and paint them black. A list A is given. All cells from this list must be painted black. Additionally, at most one cell that is not in the list can also be painted black. Your task is to determine the minimum value of k for which this is possible. So basically what you are given is, okay, let's take this test case and understand. Okay, so you are given an array A of length n. Okay, what does this represent is you have uh, some cells starting from 0 up till 10 to the power 18. Okay, so these many cells are there. Among these cells, some of the cells you are given the values of the basically the position of some of the cells. You need to paint these cells black. Okay, all these cells are initially white. All of them are white, 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 white. Okay, you need to paint these cells black. For painting, what is the condition? What you can do is you can select two cells I and j, and if the distance between the cells is less than equal to k, you can paint both of them black. Okay, these two cells should be white initially. Okay, so you can just convert two white cells. Okay, so if you have some cell I which is white and some cell j which is white, you can paint both of them. You can convert both of them to black if this distance is less than equal to k. Now, you need to select a suitable key so that you can paint all these cells black. Along with that, you can paint one more cell black, but not more than one. Okay, so finally, you should have all these n cells black and one extra cell black, or only these n cells black. Not more than one extra cell can be painted black. Okay, so this is your final condition. So basically, what you need to do is you need to select a k. Now you need to select the minimum possible value of k. You need to find the minimum possible value of k so that you can paint all these cells black. Okay, so in your final uh, answer, what you should have is cell number 1, cell number 5, cell number 8, cell number 10, cell number 13. Okay, these should be painted black. All the remaining cells, like cell number 0, it should be white. Cell number 2 is somewhere, that should be white. Cell number 3 should be white. And you can have maybe one extra cell. Okay, let's say one extra cell, cell number 14, that is black. Other than that, all the remaining cells should be white. Okay, so this is what should be there finally. Okay, so you need to select the minimum case so that you can come to this state. Okay, and how would you come to this state is select two white cells, paint both of them black if their distance is less than equal to k. Okay, so if you take k as, okay, what is the thing? If you take k as some very big value, let's say you take k as 10 to the power 18 only. Okay, it means you can just select any two cells and paint both of them black. There is no problem. Okay, distance of any two cells would always be less than that. So for very big values of k, it would always be satisfied. Okay, but you need to find the minimum value of k for which it is satisfying. So what you can do is the first thing that you need to paint these cells black. What does that mean? Okay, so always how would you paint? Initially, all the cells are white. So you would select two of the cells and paint them black. Okay, so initially, like all the cells were white. This was white, this was white, this was white, 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 and all the remaining were also white. Okay, and you need to paint these cells black. 1, 5, 8, 10, and 13. How would you do that? You would select any two cells which you need to paint them black, make both of them black. Okay. Then again, you would select any two cells, make both of them black. Okay. Now you have only one cell remaining. So here you can use that extra condition that you can paint it black by painting one more extra cell. So you would just select any cell adjacent to that which is white and paint both of them black. Okay. So one extra cell would be painted black, and this way you would paint all of them black. But one thing is for sure, if this n was odd, okay, so if this n was odd, okay, you can then select pairs of values, and then one value would be remaining. For that, you would have to use that extra cell. Okay, so for n odd, you would have to use one extra. Okay, that is mandatory. Like you cannot paint or just these odd number of black cells, because whenever you paint, you are painting two cells. So number of black cells would always be even. Okay, that is for sure. So if n is even, then what would be the finally what you can do is you can just paint pairs of cells. You cannot use that extra. If you are using that extra, it means you are painting one more cell. You are using two extra. Okay, so you cannot use two extra cells. So here there would be zero extra. That is for sure. Okay, so basically you can divide this question into two parts. For odd n, you have one extra cell. So one of them can be utilized with extra and remaining can be paired up. For even, all the cells need to be paired up. Now, you need to pair them up in such a way so that their differences, that is minimum, so that you can minimize the k. Okay, like for this case, how would you pair them? You have 1, 5, 8, 10, and 13. Okay, let's say you paired them up like this. Okay, 1 is paired with 8, 5 is paired with 10, and 13 is left. It is paired with any other. Okay, in that way, to make 1 and 8 both of them black, your case would be at least 7. Okay, if your k is less than 7, you won't be able to paint both of them black. Now to paint both of these black, its difference is 5, so k should be greater than equal to 5. Okay, so if we combine these two, it means our k should be equal to 7, at least 7. Like if k is less than 7, this condition would not be satisfied. So the maximum among all the pairings, that is the minimum k that you can get. Okay. So for what you need to do is you need to minimize the distance between the pairing. For that, what you can do is take the adjacent one. That would be the minimum distance if you sort the array. So what I'm doing is sort the array first. So first sort the array. After that, take adjacent. Take adjacent elements. So if you're taking adjacent element, that would be the minimum you can have. Okay, so greedily you can say that after sorting, just take the adjacent pair of elements. That would be the best pairing you can have. Okay, so here what you would do is, okay, this array is already sorted, you can see. So after that, what you would do is take this pair, this would be left alone. Now, for odd case, one of the members would be left alone. So one case is you are taking this pair and this pair. So you have a distance of 3. So case would be greater than, 4 here. So here you would say case would be greater than equal to 4. Here the distance was 2. Case would be greater than equal to 2. Maximum among these is 4. So your final K would be 4. That is the minimum K you should have to satisfy both of these conditions. Now, another way for that was, okay, if you have 1, 5, 8, 10, and 13, you can also have, let's say you left this one separately, that is taken with something else, and then these two 5 and 8 are paired. So it should be greater than equal to 3. 10 and this are paired greater than equal to 3. So now my maximum for this pairing is 3. So here I can do with k equal to 3 only. With 1, let's say I take with 1 I would pair it up with 2. Okay, so its distance would be 1. Okay, so for the element which is left, I can just pair it up with any adjacent element. So in a distance of 1 we can do, so that won't affect our answer. For the remaining elements, whoever I am pairing it with, just take the maximum among them. So basically for odd case, what's my final answer is, one by one I would just check one by one. If I left one, then I just pair up what's my answer. If I leave 5, then I pair up what's my answer. If I leave 8, then I do the pairing, what's my answer. So one by one, I can just leave any element and then check, and you can see the constraints that n is only 2000. You can run a n square algorithm also, that would be fine. So what we would do is, for odd case, okay, so when n is odd, okay, one by one you would assume that every element is okay. So one by one you would iterate to every uh, element. Okay, you assume that inside this you would assume that I is left. Okay, So I is like you can say removed. And for the remaining, just compute the maximum difference of the pairs, okay, of the consecutive maximum difference of the consecutive pairs. Whatever elements are left with you after removing the ith element, just take these two consecutive elements, take the maximum among their difference. That would be your k. Okay. So for all these cases, take the minimum for every like whenever you exclude the first element, whatever answer you get, then you exclude the second element, whatever answer you get, then you exclude the third element, whatever answer you get. Among them, take the minimum. That would be your final answer for odd. For even, for n as even, you cannot exclude any element. So just your answer would be directly the maximum among all the pairs. Okay. Whatever array you have, whatever array you have, just take the maximum among all the two consecutive pairs. That would be your final K. I hope you understood. If there's any doubt, you can ask. Yeah.
जो आपने ऑड वाला बताया कि उसमें हर एक वैल्यू स्किप करेंगे,
Mhm.
उसमें हम अगर इवन या ऑड जो मतलब इवन इंडेक्स वाले करें तो ठीक नहीं होगा, क्योंकि अगर हम हर एक कंसेक्यूटिव करेंगे तो ऐसा केस होगा कि लेफ्ट साइड में तो मतलब हम एक पीछे वाला एक आगे वाला देख रहे हैं डिफरेंस जो कि ज्यादा है, जो कि देखने की जरूरत नहीं पड़ेगी हमें।
हाँ यू कैन से लाइक अगर मैं जो तुम बोल रहे हो कि ये जैसे वन
अगर
फाइव
हमने 8 स्किप करा तो 8 के बाद
एट
हमें
टेन
10 करने
थर्टीन
की जरूरत नहीं पड़ेगी।
हाँ अगर हम मैं लाइक एट स्किप बेसिकली या इवन इंडेक्सेस वालों को मैं स्किप नहीं करूंगा, तो या यू कैन डू दैट, क्योंकि अगर तुम फाइव को स्किप कर रहे हो इट मीन्स तुम वन और एट का डिफरेंस ले रहे हो। दैट इज ऑब्वियसली ग्रेटर, ये मेरा बेस्ट पॉसिबल आंसर नहीं होगा। और अगर मैं टेन स्किप कर रहा हूँ तो एट और थर्टीन का डिफरेंस ले रहा हूँ, ये बेस्ट पॉसिबल आंसर नहीं होगा। सो यू कैन से कि तुम सिर्फ ऑड इंडेक्सेस को स्किप करो।
तो
तो
दैट विल ऑल्सो वर्क, राइट?
या दैट वुड वर्क। मैं क्या कर रहा हूँ, सारे इंडेक्सेस को स्किप करके चेक कर ले रहा हूँ, तो ऑब्वियसली ये वाला केस मेरा फाइनल आंसर में नहीं आएगा। ओनली ऑड वाला ही आएगा फाइनल आंसर में। तो टाइम बट एन स्क्वायर टाइम कॉम्प्लेक्सिटी इज ओके। सो इन बोथ द केसेस वो एन का एन बाई टू होगा। फर्क नहीं पड़ेगा कॉम्प्लेक्सिटी में उतना। सो
और एक
सर
चीज
बट
और है।
हमें सिर्फ फर्स्ट और लास्ट एलिमेंट एक्सक्लूड करना चाहिए सर, हम मतलब बीच वाले क्यों एलिमेंट्स एक्सक्लूड कर रहे हैं?
बीच वाले भी एक्सक्लूड कर सकते हैं, लाइक यू कैन सी लेट्स से यू हैव समथिंग लाइक दिस केस। Okay, let's say you have one, two, three, and then wait. Okay, let's say तुम्हारे पास कुछ ऐसा केस है, तुम इसमें अगर लेट्स से यू आर एक्सक्लूडिंग वन, देन इफ यू आर एक्सक्लूडिंग वन तो तुम्हारे डिफरेंस ये होंगे, थ्री एंड वन। ओके, सो देन योर आंसर वुड बी थ्री, मैक्सिमम अमंग थ्री एंड वन इज थ्री। इफ यू आर एक्सक्लूडिंग नाइन, ओके, वन टू फाइव एट नाइन, one exclude kiye, then our answer was 3. If I'm excluding 9, then our answer would be difference is 1, difference is 3, so our answer is 3. Okay, but if I'm excluding 5, okay, let's say I'm excluding 5, then 1 2 5 8 9. So if I'm excluding 5, this difference would be 1, this difference would be 1. My final answer would be 1, so which is better than 3. So I hope you understood. By excluding a middle element, it was more beneficial because these elements were more close to each other. So with k equal to 1 only, we can satisfy the condition.
Sir, can binary search and answer can also be applied here?
Yes, you can like apply binary search and then just check. Yeah, that can be applied. No
थोड़ा
problem.
हिंट दोगे, क्योंकि अप्लाई करना चाहता पर समझ नहीं आया कि कंडीशंस कैसे फंक्शन रखूं कि सेटिस्फाई कर रहा है नहीं कर रहा है।
Okay, okay. If you are doing a binary search, then what you would do, you would assume in the binary search that whatever mid you are given, that is your k. Okay, so you have fixed your k. Once you have fixed your k, you would try. If I am taking the first element, then if this difference is greater than k, that means I cannot pair this up. So you would try to exclude this first element. Okay. you would exclude this first element, then you would take this difference. This is okay, then that is okay. So you would keep on moving if you are excluding more than one element. If more than one element is getting excluded, then you would say that you cannot do it with that k. So you would have to take some greater k. You would set your high as mid plus one. And if your number of excluded elements is less than equal to 1, then you can say that yes, answer can be equal to mid, and you can try to minimize your answer, like high equal to mid minus 1.
Okay, thank you, sir.
Okay. Any more doubts in it? That binary search approach is also fine. That is another way of solving the problem, is just assume a k, apply that if this is my answer or not, then apply a check function and check whether you can have an answer with that k or not. Okay, so whenever you have two consecutive difference less than equal to that k, then take them. Otherwise, exclude one element and move ahead. If number of exclusions are more than one, then you would say that you cannot do it. Your check function would return false. Okay, I think that approach is okay. And the approach that I explained here is, for even case, you would have to take these consecutive pairs. So take all of them, and whatever is the maximum, that would be your k. For odd case, just exclude one element one by one. Okay, so if you're excluding first element, among the remaining element, apply the same thing what you did in even case. Take two consecutive, among them take the maximum. Then remove the second element. For the remaining, take two consecutive and maximum. Remove the third, remaining take two consecutive and maximum. And as you can know, you can see that removing the even index value won't be beneficial. So you can also run a loop of just removing the odd only. So that way you can just do half the operations. Okay, or running it to whole is also fine. I hope this is clear to you. Here the n was given as 2000 only, so we can run an order of n square. So that's why I did it like this. You can do an order of n square. But if n was given, let's say 10 to the power 5, where we cannot run an order of n square, this problem can also be solved in order of n only. For that, what we would do is, instead of running this two times loop, initially I can just pre-compute for every prefix what is my maximum among the pairs, and for every suffix. So when I'm excluding, so if I'm excluding for some array, if I'm excluding this index, then I would take the prefix max and suffix max. Among them, what is the max? That would be my k. Then if I'm excluding this element, prefix max, suffix max. So I can pre-compute the prefix max and suffix max. Okay, prefix max, with that I mean max among the pairs, and suffix max would also be max among the pairs. Okay, so that way I can do in order of n only. But here n was small, so I just do the brute force approach only in order of n square. Okay, I hope it is clear. There are many ways of solving this problem. So please show the approach in order of n. Okay, okay, if you want the order of n approach, what uh, I'll okay, I'll show the code for this n square approach. After that, I'll tell you. As I told you, you can do a prefix and suffix. That way you can do. Okay, I'll quickly show that code also if you wish. First, let's understand this n square approach and that I explained you. Okay, so what I'm doing is, this is the input part. Then I sorted the vector. Sorting is the first thing. If n is 1, that case is handled separately. If n was 1, that means there is just one element. So that can be paired up with any adjacent element. So you just require a k of 1. Okay, so your case would be 1. So that I've handled just separately only. After that, if n is even, then I would say for even case, what I need is maximum among all the pairs. So initially, I would assume my answer is the difference between the first two elements, a1 minus a0. Then I'll iterate to all the other pairs from I equal to 2, I plus equal to 2, ai plus 1 minus ai. Okay, this would be the next difference. Maximize it with my answer. Okay, so just take the maximum among all pairs of all these adjacent pairs. Okay, and that would be my final answer. So for even case, we are not excluding any element. So this would be simply my answer. For odd case, One by one, I'll iterate to every element and say that this I is excluded. Okay, so if this I
Excuse
is
me.
excluded, yeah,
Sir, are you showing your screen?
yeah, it's not
I'm
visible.
in the code.
Yeah, yeah.
Your code is not visible.
Okay, sorry, it's not visible. Okay, is it visible now?
Yes.
Okay, my code is VS Code is visible, right? Okay, okay, okay. I'm sorry for that. I'm explaining the code again. Okay, what I'm doing here is this is my input part. I've taken the input. After that, I've sorted my vector. Okay. Then for n equal to 1 case, this I'm handling separately. That if n is 1, I only have one element. Then I would just see out 1 as my answer. If I have only one element, that is just the excluded element only. It cannot be paired up with anything. So it would be paired with any adjacent one. So pairing with any adjacent would require k to be at least 1. You cannot pair with the same I. So your final k would be 1 for n equal to 1. Then if n is even, what I told you is what I'm doing for even case is I would just take the maximum among all the pairs of differences. So the first difference is a1 minus a0. So a1 minus a0 is the first difference. After that, that I've initialized my answer with. After that, I run a loop from I equal to 2, I plus equal to 2. I'll go to every alternate index and take this difference a of I plus 1 minus ai. Okay. So I'll go to I equal to 2, take this difference. I'll go to I equal to 4, take this difference. Likewise, I'll maximize that with my answer. And that would be my final answer basically for even case. That's the only thing you can do is take the maximum among all the pair of just pair up all the adjacent element. You cannot exclude any element in the even case. Now for the odd case, you can exclude one of the elements. So I run a loop where if I am running from 0 to less than n, so my ai, that element is excluded. Okay, so if I'm excluding the ith element, I'll create a new vector that would have the elements that are not excluded. So if j is equal to I do a continue, all the remaining elements are pushed back in v. So I created a new vector with all the elements except the ith element. Now in this vector, I would apply this same algorithm. Okay, that just take the maximum among all the pair of differences. So my mx is v1 minus v0, and then this same algorithm. Okay, so these two four lines are the same as here. Okay, this much. I computed my mx. This was my k for when AI is excluded. Now, what's my final K is the minimum among all these cases. So if this was MX, I take the minimum of answer comma MX. My initial answer is initialized to infinity, which is some very long value. Okay, it's in 64 max. So after that, whatever answers I get, I take the minimum among them and I print my final answer. I hope this even case is clear to you. So this was it. This was the code. Its time complexity would be order of n square. You can see this sorting is order of n log n. Okay, and then this is order of n, a single loop. Okay, this so even case is working in order of n. For odd case, this loop is running n times. This loop is running n times. So overall, this is order of n. This is again order of n, which is running n times. So this is order of n square. So my final time complexity here would be order of n square, which would be accepted given the constraints. Now, if the constraint was high, you needed to do in order of n log n. So that also I'll show you. What you just need to do is this thing that you are computing here for every time, you can compute that in a prefix array. So what you can do is you can initialize a prefix array of size n0 and a suffix array of size. Okay, I'll write the code and give that in description. I'll just explain you the logic what you need to do if you want to solve this problem in order of n only is whatever you are taking, if let's say you are excluding this 5, what you would need till here, what is the these some maximum among the pairs we have till here. Okay, if you are and plus till here whatever maximum among pairs. So I'll initialize a prefix array which would have till index I. Okay, till index I, whatever the pairs that we have, the maximum among these pairs. Okay, so till index I, that would be denoted by my prefix I, and my suffix I would denote from the end till index I. Okay, among them, what is the maximum among these pairs? Okay, so these two I would pre-compute. After that, in the loop, I would just run it for all the I would just run it for all the odd indexes only. So if I'm excluding an odd index, I would have an even length here and even length here. So that for even length, I can compute this prefix and suffix. Okay, so I would run the loop for all the odd indexes, and for I would take prefix I maximum among. Okay, so I'll run a loop for I from uh, basically all the odd in even indexes in zero based, you can say even indexes for all the I from 0 to n with +2. Okay, that way I would go and take the maximum prefix I minus 1 and suffix I plus 1. Okay, this maximum would be my k. Okay, so this would be like my mx is this. Then with answer, I would take the minimum among mx comma answer. Okay, so this way I would do if I want to do in order of n. Okay, I hope it is clear to you. Like, if you wish, I'll write the code on like quickly. Okay, I'll attach the code in the description. No problem. I hope you understood this order of n approach. Okay. Okay, let's move to the next problem. If you have any doubts in this problem, you can ask. Okay, so let's move to the next problem, which is problem C. There is a shop that sells action figures near Monocarp's house. A new set of action figures will be released shortly. This set contains n figures. The ith figure cost I coins and is available for purchase from day I to day n. For each of the n days, Monocarp knows whether he can visit the shop. Every time Monocarp visits the shop, he can buy any number of action figures which are sold in the shop. Of course, he cannot buy an action figure that is not yet available for purchase. If Monocarp buys at least 2 figures during the same day, he gets a discount equal to the cost of most expensive figure. Okay, basically what it means is there are some set of action figures. Okay, and that set contains n figures. So basically you are given that every ith figure, it cost I coins, and that can be purchased in from day I to day n in any of the days. And you are given an like an array, a string, 0 1 string, where it denotes then on the ith day will Monocop go to the shop to purchase something or not. If he goes to the shop to purchase something, what he can do, he is he can purchase only something one item at the cost at its cost. Or if he is purchasing more than one item, at least 2 items, then the cost of the most expensive figure that he would get for free. Okay, so that is an offer that if in a single day he's purchasing 2 or more items, then the most expensive figure that would be free for him. Okay, so you just need to find in minimum with the minimum coins spent, what is the minimum coins that Monocop would need to spend in order to purchase all the items one time. Okay, he cannot purchase anything more than one time. He want to purchase everything exactly, all the figures exactly one time. So what is the minimum amount of money he has to spend? Okay, so like let's take this test case and understand. Okay, here n is given as 6. What does that mean? That there are 6 items. Item number 1, 2, 3, 4, 5, and 6. Okay. Item number 1 cost 1 coin. Item number 2 cost 2 coin. 3 cost 3 coins. Okay. That is what is there. Now, from day, okay, these are the ith item cost I coins. So if he goes to the shop on day 1, it would have all. So this item number 1 would be available on day 1. After that, it would be available say till day 6. This item number 2, it would be available on day 2 till day 6. Item number 3, it would be available on day 3, and till day 6 it would be available. 4 would be available till here, till here, till here. Okay, this is the availability of that item. Now he has to purchase all these 6 items in minimum cost. So uh also this string is given. It means it, if you are given, if you index them as 1, 2, 3, 4, 5, 6. Okay, so on day 1, it is 1. It means he visits the shop on day 1. Day 2 is 0. It means he doesn't visits the shop on day 2. Day 3 is 1. It means he visits. Day 4, he visits. Day 5, he doesn't visits the shop. Day 6, he visits the shop. Okay, so if on day 1 he is if he is not visiting the shop, then on that day he cannot purchase anything. And that's basic. Now, on those days where he is visiting the shop, you need to optimally provide a way for monocop so that he can buy all the 6 items at minimum cost. Okay, so one possible way is on day 1 he visits the shop and buys this item. Okay, so it would cost him 1 coin to buy this item. On day 3, he visits the shop and this item number 3 is available to him. One is already bought, he cannot buy it again. So only one item, either he can buy it or not buy. Let's say he doesn't buy it. Okay, so no costing. But this item is done. This item is not done till now. Okay, this item number 2 was also available on day 3. He didn't buy any of them. Let's say on day 4, he bought, let's say this item number 2, 3, 4, all the 3 he bought. Okay, so if he buys all the 3 items, item number 2, 3, and 4, the cost he would have to spend is, the maximum among these is 4. So 4 would be excluded, 4 would be for free. He would only have to spend 2 plus 3 coins. Okay, that much only he would have to spend. This 4 he would get for free. Now on day 5, he doesn't visit. On day 6, okay, so on day 6, he would have to buy all the remaining items because he has to buy all the items. So let's say on day 6, he bought item number 5 and 6. So that would cost him 5 coins and this 6 would be for free. Okay, so on this day, it cost him 5 coins. Okay, so overall, the number of coins is 1 plus 2 plus 3 plus 5, which is a total of 11 coins. Okay, so this was one way of buying, that on day 1, he bought item number 1. Day 3, he didn't buy. Day 4, he bought all these 3 items. Day 6, he bought these 2 items. Okay, if he was buying in this way, his total cost would be 11. Let's see for this test case what was the best. For this test case, the best was 8. How? On day 1, he buys the first and third on day 3. Okay, so how he got 8 is, on day 1, he didn't buy anything. On day 3, he bought the first and third item. Okay, so this third was free. Okay, so initially none of them are bought. On day 3, what he did is, on day 1, he didn't buy anything. On day 3, he bought the first and the third item. Okay, they are bought. It would cost him just 1 coin. This item 3 would be free. On day 4, he bought the second and fourth item. Let's say he bought the second and fourth item. Then that would cost him 2 coins. This fourth one would be free. Okay, so these both are bought and it cost him 2 coins only. This fourth was free. On day 5, he doesn't visit. On day 6, he buys both the item number 5 and 6. They both are bought and that would cost only 5 coins. This 6 would be free. Okay, so in total 1 plus 2 plus 5 is, in 8 coins only he is able to buy all the items. So this 8 was the minimum. The best possible way with minimum coins he can buy all the items was 8. So this was the answer for this test case. I hope you understood the problem, what you need to do. Okay, so how can you now minimize this? Okay, so what you can do here is, One thing is given here that for the nth day, it is always 1. That Sn is 1, so monocop is always able to buy all the figures on the nth day. Okay, so now you know that on the nth day he can buy. This last index would be 1, so he would definitely go to the shop on the nth day. Okay, so on this day he can buy all the remaining items. So how would he optimally choose on which day what to buy so that the cost is minimized? So how is the cost being minimized? Whenever he buys more than 2 items, more greater than equal to 2 items, then the most expensive item is for free. Okay, so one of the items get free when he buys 2 items. Okay, so if there are n items, let's say he's buying two items, so the number of times he buys two items, one item would get free. So you need to maximize the number of items that are free. The total cost of the free items is what you need to maximize. So would it be better to buy two items, or 3 items, then 3 items, then 2 items, something like that? So it is always better to buy 2 items, because if you are buying three items 2 times, you are making only two of the items. Okay, one item here and one item here is free. Instead, if you are buying two items, then one from all the three is getting free. So it's always better to choose just 2 items and get one, pay for one and get one of the free. You need to maximize the number of free items. But maybe the number of days where you are visiting, that is also limited. So if you are just buying two items, that would take you n by 2 visits to do it like that. But if these number of ones, the number of visits is less than n by 2, then sometimes you would have to buy 3 items so that you can buy all the items. Okay, so these are the initial observations. Now, which is the item that you would buy for free? Okay, so if you are going to the ith shop, okay, let's say you are going to the ith shop, you have some items available. Now, if you are going to the, like, on the ith day, basically, if you are going, so if you are going on the fourth day, that means till day 3, whatever, wherever you have visited, this fourth item was never bought, because it is available for purchase today only. So this, whenever you are visiting on the ith day, the ith item would always be available for purchase, and that would be the most expensive item. Okay, because on the ith day, all the items from less than I up till I, they would be available for purchase. So the most expensive item is the ith item, and this is the item that would be there for sure. So if you are buying more than 2 items on the ith day, it means this item is getting free, that you know for sure. So one more observation is, if you are buying on the ith day, if you are buying more than 2 items are bought, then free item, you would say the free item is the ith item, that you know for sure. Okay, so basically, what's like finally what you need to do, you need to make the maximum sum of free items, that you need to like maximize the sum of items that you are getting for free. That is the thing. If you maximize that, then your final answer would be minimized. Okay, so what's your like final cost? You can say that the final cost is like total sum up till I, like from 1 till n. This is the total cost if you're paying for all the items, minus the sum of free items. Okay, that is your final cost. So if you this thing is constant, sum from 1 to n, this is always constant. This is the thing that you can change. So you basically need to maximize this thing. Okay, so you need to maximize this thing in order to minimize your answer. Now,
Abhinav,
yeah.
yeah, final cost would be total, not total sum, right? 1 plus till n minus 1, right? Because nth item will always be free.
That's what I'm telling. The total sum from 1 to n minus the sum of free items. Okay,
Oh,
so that would be included here.
okay.
Okay. So my final cost is the total sum minus the sum of free items. And like as I said, nth item would always be free because when you're going to the nth shop, okay, it's not necessary that it would be free. What if you're going to the nth shop and only buying this item? Then it won't be free. If you're going to shop every day and buying one item, then you would have to pay for every item. Okay, but you would not do that. The best, like in the best case, you would always try to maximize the number of free items. So how do you maximize this? Okay, that you need to find. So basically, whenever you are going to the shop, if you are going to the shop on the ith day, then you can make ith item free. Now, what is the condition to make it free is if you buy one more item along with that. Okay, if you buy one more item along with that. Okay, so if you want to make one item, if you want to make ith item free, you would have to pay for some jth item which is less than I. Okay, the available items on the ith they would be all the items less than I. Okay, so among the items less than I, you would have to like pay for one of the items to get the ith item free. Okay, so now you
One,
want to yeah.
why is it optimal that at ith day we want to make ith item free only? Say example, we delegate the ith item to some other day when we visit, say I is 1 in that case, and purchase some j minus I minus 1, say example, at free cost.
Okay, so like you are telling that if I'm going to the on the ith day, if I'm let's say on the fourth day, if I'm going to on the shop, then I'm not buying the fourth item. Rather, let's say I'm buying the second and third item and making
Three
the
free.
third item free.
Yes.
Okay, so so now like let's think, would it in any case would it be better to do something like that, or would you always buy the item? So if you want to, if you are let's say on the fourth day you are buying item number 2 and 3. Okay, let's say on the fourth day you're buying item number 2 and 3. Okay, that you could have done on the third day also, but you are saying you were not able to do this. Let's say this 3 was a cross here, there was a 0.
Say
So
example, you can consider 0001011.
yeah, I got what you're telling. Okay, let let's say you had 0 and then on the
Mm,
fourth day you tried to make this third item free by on the fourth day. Okay, so you made the third item free. Now when you are moving ahead, okay, let's say on some day you would make some other item free. So was it like if you're not making the fourth item free, maybe on some other day you would make the fourth item free, or if you're completely not making it free, then was it not okay, there can be two cases that
yeah, if
after
we are
the
not making it free, then it would be optimal to purchase it there itself.
yeah. So what the thing is, if you are on the ith day, if you're not making the ith item free, then either it could be the case that finally you are purchasing it or you are making it free on some other day again. So if you are finally purchasing it, then it was like optimal always to, instead of purchasing this, you could purchase this 3 and made it the fourth one free. That
Yeah,
was better.
yeah.
And if you are finally making it free on some other index, then like cyclically only you can say that whichever at whichever day you are making this fourth free, then for the that day again you can apply the same thing, that it was better to make that item free instead of making that free. So
Can you
this
consider, say, 0001011?
okay, 0001011.
Yeah.
uh,
Uh,
Okay, 0, 0. So this was available. This fourth was available, and
Say
fifth,
example,
sixth.
for today I don't decide to purchase, but I try to optimize third cost. and
Okay, so in this day you try to make this third free, and then on the sixth day, or
I'll try to make fourth free.
you'll try to make fourth free. Then
But
on the seventh day, you would like, let's say you made seventh free. So what I'm telling is, if on the fourth day you made something else free, then
mm,
you're making fourth free on some other day, and
mm,
then finally you this loop would end somewhere that this six is not getting free. You are purchasing this. Okay.
right.
Finally, on the seventh day, you would make the seventh free, not six free. Okay.
Mm,
So if you're making something earlier free, then you would go on a cycle where at the end there would be some value which is not made free, which is purchased.
and
So
that would be
you,
always be greater value.
yeah, so that would be always greater value. So like cyclically, you can say that it was better to purchase six instead of four, make six free instead of four, and it was better to make four free instead of three.
Uh,
Okay.
will delta be like valid in this case? Say example, I'm achieving one difference here. Like,
Yeah.
do like differences also come into play, or uh, like
Like
how do
with
you think?
what difference you're telling? Like basically, you need to maximize the sum of items that you are making free. Okay, so on every day you can make at max one item free. So if on the
Mm,
fourth day you are deciding to make the third item free,
right.
and
Yeah.
you can make the fourth item free, it's always better to make the fourth item free instead of making the third item free. Uh, like on any day you can make only one item free, so it's optimal to make the most expensive item free, so that finally like you can
Okay.
maximize the sum of free items.
So by formula, we can see like we'll be purchasing even if we don't consider differences. So we will be subtracting free items, and if we are like in cyclicity, don't decide to purchase fourth at fourth day, but at some point we'll be purchasing some higher cost when the loop ends, then that
Yeah.
will not be free. So that will add to the cost, right? That's the
Yeah, yeah, basically your sum of free items is not maximized cyclically. You can say you could have increased this sum of free items if you were making fourth free on the fourth day and sixth free on the sixth day.
okay. Got it.
Okay. So I hope this thing is this greedy thing is clear to everyone, that why on the ith day we would only make, if we are making some item free, that would be the ith item that you are making free. So on basically there would be some days where you would make on the ith day you make the ith item free, on some other ith day you make the ith item free. So basically how many like what's the maximum sum of items that you can make free, that would be your final answer. Now the cost for making the ith item free is buying one item from the back. Okay, that's the thing. So what you can do greedily is just start, if you start from the back. Okay, so it's always best to make the greatest item free. Okay, so whatever is your n. Okay, so if n is 6, so first for n you would definitely try to make the nth item free. Now to make the nth item free, that would make you pay for one of the items before. Okay, so what would be the item that you would try to pay? You would try to pay from the lowest item. That would be better. Okay, so basically that means if you are making the sixth item free, there is one item from before that you would not make free. So what you would do, you would start from the end. If n is if the ith is there is one, you can visit the shop that day, then make it free. And in your counter just start with c equal to 0. In your counter just do a +1, that you are making this free. Okay, but that would take the cost of some item which you are not making free. uh, okay, so if your c becomes 1, that means while moving back there, at least one item should come that is not getting free. You cannot make all the n items free, like with that, now when you move to 5, when there is a cross, like when there is a 0, you don't visit that shop. That means if you're not visiting that shop that day, you are not making that item free, that's for sure. Because uh, if you are for the item which, like as I explained earlier now only, that if some item there is a zero to some item, then you can make it free for by some other I which is greater. Okay, some day which is more, like to make the fifth item free, you would have to make it free on some sixth day. But on sixth day, it was better to make the sixth item free only instead of making it the fifth item free. So whenever you are moving to an index where SI is zero, then you would say that that item is not free. Now that item is not free, then that item can be used to make some item free from ahead. So you would do a C minus minus. Okay. So what I'm doing is I'm moving from, I'm like greedily moving from the end. If SI is zero, okay, so what I'm doing is I'm moving
Uh,
for I from n to
small,
1. Yeah.
like, will this argument apply to zero as well? Like, if you want to, would it be easy to make it free, or like it would be cyclicity wise better to purchase?
Zero what? Like as I explained, when SI is zero, that only,
Yeah,
no?
yeah. Should we make it free or should we couple it?
It would never become free when SI is zero, because to make it free you would need some I greater than that. Now, like to make 5 free, you would need to use it at some sixth day, but on sixth day it was better to make the sixth item free instead of making the 5 free.
But for making five free, you'll have to couple it with a lesser item, right?
For
Not.
making, yeah, but that can be done only 5 is available after the ith day only. So to
Mm,
make 5 free, that can be done only on the sixth day or seventh day or eighth day. So
mm.
if you are at some seventh day, then it's better to make the seventh item free instead of making fifth free.
It's the same cyclicity argument,
Yeah,
right?
same argument.
Okay. And what does your C counter denote?
Okay, that I'm explaining. So what does it denote is I'm moving from the back. So if I'm making this sixth item free, it means to make this sixth item free, I would have to use some item before that, which is definitely not getting free, the item that I'm using it. So this C denotes that if C is 3, let's suppose, that means if I move till here, then the number of items that I've made free is 3 more. So before that, like I would have to use 3 of the items that are not getting free in order to counter that. Okay, so like I'll explain you would understand here. What I'm doing is I'll tell you the pseudocode. I'm moving for I from n to 1. What I'm doing is if Si is 1, if Si is 1, then I would like make that item free. Okay, so make it free. So just like subtract the value from my answer. I would initialize my answer as total sum. When I'm making an item free, I will just subtract the cost of that from my answer. Okay, that means I'm making it free, and I would do C++. And if Si is 0, then what I'm doing is just C minus minus. Now, what is happening is whenever I'm making an item free, I'm increasing this counter C. Whenever I'm not making an item free, I'm decreasing this counter C. So what is happening whenever I'm at some I? So C is just keeping the counter of how many, just like till C is basically that from I to N, number of free items minus number of like not free items. Okay, that only it's keeping. On every free item I'm doing C++, on not free item I'm doing C minus minus. So difference between number of free items and number of not free items. Now I know for sure that this C should be like less than equal to 0 at the end, because if the number of free items are more than number of not free items, that is not valid, because to make every item free I need a item which is not free to make it free. So my final C, at every step this C should be like basically till the end, at the end, this C should be less than equal to 0. Okay, the number of because the number of free items should be greater than equal to number of not free items. So my finally, if this is greater than the number of not free, like less than the number of not free, the number of free items are less than the number of items that are not free. Basically, this C is negative or 0. Okay, so I have to make sure that this at the end, this C is less than equal to 0. So how I'm making it sure is whenever I'm moving, I would make it free, do C plus plus. I would not make it free, do C minus minus. Now let's suppose you have some this case. Okay, you have something like this. This is your given string. When you are at this item, okay, this is 1, 2, 3, 4, 5. You made this item free. Now, when you are moving to this item, you made it free. When you move to this item, you made it free. Here also you made it free, and this was not made free. But you are telling that you are making the 4 items free, but for that only 1 item. But for every free item, there should be a corresponding not free item. So that I would maintain by making sure whenever I'm making an item free, there should be some item. What I can do is just start from the start, and whenever there is 0, just but that would like take order of n square complexity, or that won't be optimal because basically when you are making an item free, you can make any one item not free. So if this is made free, then if there is a 0, immediately you would say that for this not free item, for this free item, I would have this not free item. Okay, they would get paired up. But if there is another one, that means I would try to make both of them free, and then maybe pair them up with some not free, not free. Like that I can do. Because what I need to do is I need to have more number of free items in higher value. Okay, I need to maximize the value of free items. So if there is a 1, I would make it free, but making sure that if I've made these 2 items free, my C counter is 2. Now, if I'm making this item free, my C would become 3. But if my C becomes 3, it means for the remaining 2 items, 3 items would become not free, which is not valid. So I cannot make this item free. Basically, after making 2 items free, I cannot make a third item free. So here I would say, although this is 1, still I would make it n, because this C plus 1, after this C is increased, it would become C plus 1. That is more than the number of remaining items, which is I. Okay,
Will you break
so
at this point out of loop?
no, I would not break this out of loop, but instead I would make it, I would assume that this is 0 and make it not free and increment my C plus plus. That way, when I move ahead, I can maybe make some, because this n is utilized for some other, then somewhere I can make some other item free.
But at
But
point
yeah, I think breaking would also be fine. Yeah.
yeah,
If
like
you're
this clearly implies that you have lesser items, and since you want all these CA to be counteracted, you
yeah.
all of them to be like
Yeah, yeah. Whenever you encounter this case, you can actually break out of the loop, because once this case is there, it means all the remaining items should become not free.
yeah, to optimize the cost. Yes.
Okay. So what basically you would do whenever you come to this case, you would just break and just assume remaining becomes not free. Okay, like in my code, what I did, instead of breaking this, I did a C++. But finally, even by doing this, you would have all n only. Okay, so both of the things are fine. So what I did here is, before checking this SI is 1 or 0, before that I added another if this C plus 1 is greater than I, then I would go to this else case directly. So I would just directly do C minus minus. You can write a break here. Both of them are fine. Okay. And just I did C minus minus and continue here. Okay. So both of them are fine. Either do a break or C minus minus and continue. So I
When
hope this.
when are you adding to cost? Like in the
When I'm making it free, I'm reducing my cost. Basically, my final answer, I'm doing minus equal to I. Okay, initially I have stored this total sum as my answer.
Okay, okay.
Okay, or what you can do is instead here you can add to your answer. Okay. Okay, whenever you are, an item is not free, that is only adding to your cost. So here you can add to your answer the cost of I. Okay,
Yeah, makes sense. Yes.
so I hope this logic is clear to everyone and this pseudo code is also clear. So let's move to the actual code to understand what I am doing. So I have taken the input, this n string s, then I've initialized my answer as 0 and this c counter as 0. Then I'm moving in reverse direction from n minus 1 to 0. Like I'm taking a 0 based indexing. You can take 1 based also, although there is no array here. So there was no use of taking a 0 based. You can directly run a loop from n to 1. That would be better. But okay, like during the contest, I did it like that. So I'm showing it this only, that I'm moving from n minus 1 to 0. And then if c is greater than equal to I, since my I is 0 based, so uh, this condition was c plus 1 greater than I, which is c greater than I minus 1. So my I
This
is I
condition is
minus 1 only here.
like current cost is greater than number of remaining elements, right?
Yeah, the current c, which is how many number of free items are exceeding. If the exceeding number of free items are greater than remaining items.
So remaining item should be I minus 1, right?
Yeah, like I'm taking 0 base. So when I'm at
Okay.
ith day,
Yeah.
then
Yeah.
I is the remaining items.
Okay.
Okay, so if that is greater, if c is greater, then to answer I would add I plus 1 because I'm taking 0 base. So on the ith day, the cost is I plus 1. So I would add that cost and do c minus minus and continue. Okay. This is the case when uh, my number of free items, the difference between free and not free is exceeding the I. So I can write directly a break here or just add all the remaining sum to my answer. Okay. So that is one case. Now, if that is not there, that case is not there, then I would just check SI. If SI is 1, do a C++. That means this item is made free, but that would take a C to basically one not free item is needed to encounter it ahead maybe somewhere. Else part, I do answer plus equal to I plus 1. So I have taken a 0 based indexing. So the cost is I plus 1 instead of I. So I do I plus 1 to my answer and do C minus minus. If C becomes less than 0, I do C equal to 0. That is also there, that if at some part, let's say I have 0 1 0 0 1, okay, or 0 1 1. Okay, if something like this is there, then if I start from here, I have a 1. My C was 0, it became 1. Okay, I made it free. Now when I move here, my C became 0 again. When I move here, if I'm making C minus 1, okay, that is not making any sense here because I'm you can only use this item to make some item free ahead of this. So if I'm doing C minus minus, it means I'm using this item to make this item free. So I would, if C is going negative, I would keep it 0 only, so that when I move to this item and make this item free, my C should become 1. This item requires one item from the left to basically encounter it. If my C was minus 1 and I made it 0, it means this is basically made free by this item, but you cannot do it. If you are on the ith day, you can make it free by some item from the left only. So if my C is going negative, I am doing C equal to 0 again. Okay. Because C denotes the number of items which have already been free, but it needs some not free item to overcome it. Okay. So I hope this thing is clear why I am doing this. If my C is getting negative, I made C equal to 0 again. So after this loop, I am just printing my answer. I hope this code is completely, this logic is completely clear to you.
Yeah,
So
like this is clear, but I want to understand like how did you what was the thought process in establishing the thing that at ith item, that cyclicity thing, was it like, did you do some examples or like
Uh,
um
yeah, basically, like
or
I
did
told you, basically it was greedily only just by looking at some examples only you got to that thing. Like uh, from examples and all, like from greedy approach, just by thinking only you, if you see the nth items, like you were sure that you are going to make the nth item free because this is of maximum cost. Whenever you are at ith item, like from the examples only, every time you saw that whenever you are at ith item, you are making that ith item free. So from that, the greedy thing comes to your mind that when you are at ith item, you are making the ith only free. Why would it be better to make something less than it of it
like I
free?
was stuck in the loop ki like make lesser free, then make this free sometimes later.
Yeah,
Uh,
but the problem here was in one day you can make only one item free.
one item free, correct.
Yeah. So if more than one item were able to be made free, then you can make some item free from the previous day also. But in one day, if you can make only one item free, then it's best to make that item, ith item only free because that's of maximum cost.
Yeah, that's what I'm saying. Like, did you establish this by writing some examples or like just thought process only later?
Just, I would say thought process only just by looking at the examples and all and
Okay,
thinking.
okay, got it then. Yeah, thank you.
Okay. Okay. I hope this problem is clear to everyone. So we would move to the next problem now. If you analyze the time complexity, this input, this string is of size n, and this loop is running n times. Inside, we just have if else condition, which are of order of 1. So this is an overall order of n only. So the time complexity is order of n. Space complexity is also order of n only. You just have a string of size n, which is taking n space, nothing else. Okay, I hope this problem is clear. We can move to the next problem now. Okay, so let's move to problem D, where you are given a sequence of integers a1 to an. Let S of L to R be the sum of elements from AL to AR. That is SLR is the sum of elements from AL to AR. Let's construct another sequence B of size n into n plus 1 by 2 as follows. Okay, so this sequence B is sum from 1 to n, sum from 1 to 2, sum up till sum from 1 to n. Then sum from 2 to 2, sum from 2 to 3 up till sum from 2 to n. Then sum from 3 to 3 likewise. This sequence of n into n plus 1 by 2 is created. Like if you have an array A, this your array B would be this 1 is here. Then 1 plus 2, which is 3. Then 1 plus 2 plus 5, which is 8. Then 1 plus 2 plus 5 plus 10, which is 18. Okay, this is done. Then you would start from 2. Okay, so 2 is here. Then 2 plus 5, 7 is here. 2 plus 5 plus 10, 17 is here. Then you would start with 5. So 5 is here. 5 plus 10, 15 is here. Then you would start with 10. So 10 is here. Okay, I hope you understood how this sequence B is created from sequence A. Now, you are given Q queries. In every query, you are given two integers L and R. Just calculate the sum from L to R. Okay, basically, you need to calculate the sum for the range from L to R in this array B. Okay, which is created from an array A of size n. Now, this n is given as 3 into 10 to the power 5. So if you are creating an array of this is order of n square. So you cannot create a you cannot just directly create an array and then to calculate the sum from L to R take a prefix sum. That direct thing cannot be done because n square would give you memory limit and time limit both exceed. Okay. So this is the problem here. So now you just need to answer these Q queries. That's the question. Okay, so if you look at this first, basically you this array was given to you, this array A. So if array B is this, according to that, the sum from 1 to 1. Okay, so this sum from this is index 1. So sum from 1 to 1 is 1. First query was 1. Okay, then sum from 1 to 2. 1 to 2 is this range. This sum is 1 plus 3. Your answer is 4. Okay. Sum from 1 to 3. Okay. So this range 1 plus 3 plus 8, which is 12. Okay. Likewise, you have to answer the queries. Okay. So let's see how can we solve this problem. Okay. So basically you are given some n-sized array. Okay. And then you create an array B. Now what that array B is, that array B is the, you can say the sum from initially, like you can divide this array B into groups. First, when you start with 1, then you have this 1, then 1 plus 2, then 1 plus 2 plus 5. Okay, basically the prefix sum. If you constitute the prefix array of that, then you would have 1, 1 plus 2, 1 plus 5, 1 plus 10. Okay, so initially you have this prefix array. Okay, then 3 plus 5 is 8, 8 plus 10 is 18. Okay, initially you have this. After that, you have a prefix array starting with 2. So you have 2, 2 plus 5, 7, 7 plus 10, 17. Then you have a prefix array starting with 5. So you have 5, 5 plus 10, 15. Then prefix array starting with 10. So this is your array B. So first thing that I did is divided this array B into groups. Starting with 1. So the prefix, this is the prefix array starting with 1. This is the prefix array starting with 2. This is the prefix array starting with uh, the third index. Prefix array starting with the fourth index. So this is how you divide this array B. Now, for every query, you would have a range from L to R. You need to find the sum from index L to index R. Okay, let's say this L is, let's say L is 4, R is 9. So your fourth indexing would be like this. This 18 would be at the fourth index. Then indexing would be 5, 6, 7, 8, 9, 10. Okay, so 9 would be like this. So you would have to add 18, this and this. Okay. So the first thing is you have to compute this sum. Now you cannot do some brute approach and all. Even creating this array B is not allowed here because n is up to 3 into 10 to the power 5. So anything order of n square, this array size of the array B is only order of n square. So you cannot create this array B. That's the first thing. If we were able to create this array B, then just create this array B and compute a prefix array for this B. Through the prefix array, you can compute the sum of any range in order of 1. That would have been fine. But now you need to compute the sum of this range in order of 1 because there are q queries. Okay, q queries, q is also up till like some 10 to the power 5, 3 into 10 to the power 5. Okay. So q is up till 3 into 10 to the power 5. Let me just check. One of my solution got hacked. Which one is that? Solution A. Okay, sorry. I think the solution that I explained to you, that would have been okay. Okay, the solution that I gave you for A is okay. What I submitted in the contest got hacked. Okay, no problem. Okay, for problem D, okay, what I'm telling is for the range from L to R, you need to, okay, you need to compute this sum from L to R in some order of 1 because Q is 3 into 10 to the power 5. Okay, order of 1 or order of log n you can go at max. You cannot do an order of n or order of n square for each query. So you would have to do some pre-computations so that you can do this. Now, how
And
can you
login will also work.
compute? Like, yeah, Q into log n would work if you can compute for every query in log n. That would also work because Q is 10 to the power 5, log n would be very small. Okay, so now how can you do this is, so first observation is how I wrote this array. I divided this array into groups. First group is this prefix sum starting with 1. Second group is this prefix sum starting with 2. This is third group. This is fourth group. So for any array of size n, there would be n groups. Okay. First group starting with prefix sum starting with 1, prefix sum starting with 2, prefix sum starting with index 3, prefix sum starting with index 4. Likewise, there would be prefix sum starting with index n. So I can divide this array B into n groups. Okay, that's the first thing. Now, whenever I want to compute the sum from range L to R, so what I would do, if I can find out that this L belongs to which group, okay, and this R belongs to which group. Let's say this L belongs, for this case, L equal to 4, R equal to 9. This L was here. So this L was belonging to group 1. Okay, this is my first group. This is my second group. This is my third group. This is my fourth group. L was belonging to group number 1. And this R, which is 9, this is belonging to group number 3. This is belonging to group number 3. So one thing, if you can compute the sum of every group, then we would say that if L is somewhere in group 1, R is somewhere in group 3, for all the groups in the middle, their complete sum would come. Okay. So if I can somehow calculate the sum of every group, if I can pre-calculate, there are n groups, if I can pre-compute the sum of every group, then one thing I would say that if I want to compute the sum from group 1 to group 3. Okay, so this group 1 would come partially because L is, if somewhere here only 18 is coming, this is not coming. This group R, here both of them were coming. If R was, let's say, 8, if R was 8, still it would belong to, this would belong to group 3 only, but only this would be counted, this ninth index won't be counted. So I would say that in group 1 I have something partially, in group 3 I have something partially, but all the groups in the middle would have completely. Okay, so one thing I can say is sum of some consecutive groups. So if I can calculate the, for every group, so for group I, what is my sum, if I can pre-calculate that, then for the groups whose complete sum is coming, that I can directly compute by calculating the prefix sum of this group. Okay, so this partial thing we would see how we would compute. One thing for sure, for the groups in the middle, okay, their complete sum is coming. So here I would say that the sum from group 2 to group 2, okay, only group 2 was in the middle, there can be more than one groups in the middle, so their complete sum, I would say the complete sum from group 2 to group 2, that would come. So if I can compute the sum for every group, then I can compute a prefix sum for every group. Okay. So through prefix sum for every group, I can compute this complete sum from range L to R. That would be prefix sum for group. Basically for 2 to 2, it would be 2 minus prefix sum of group 1. Okay. Okay. Whatever L to R we want to compute, prefix sum of R minus L minus 1. Okay. So if we can compute the sum of every group, then the sum of the complete groups that are coming in the middle, that can be calculated. After that, we would have to compute these partial sums. Okay. So we would have to find a way to compute these partial sums. Okay. For uh, any range belonging to V, if we got the group number, then from that group number, we would have to we would know in that group number starting from this how much we want to compute. Okay, so let's see how can we do that. So first thing, how can we compute the sum of any group? Okay, let's analyze these groups. First group is this prefix sum group. Okay, just if we have this array A, just calculate the prefix array. Prefix array would have 1, 3, 8, 18. Okay, so the first group is same as my prefix array. Okay, now what about the second group? In this, so what is the sum of the first group? Is if you do the sum of this prefix array, okay, this would give you 4 plus 8, 12, 30. Okay, so for the first group, I would say that my the sum of groups that I'm calculating for the first group, it is 30. What about the second group? What is sum of second group? Now, what is second group? Now in the second group, we would be starting with 2. So from this, how can we transfer to the, like from this, how can we transfer to the second group? Is from 1, if you do a -1, from 3, if you do a -1, -1, -1, then this would become 0, -1, 2, 8 -1, 7, 18 -1, 17. Basically, if you are starting a prefix sum from 2, that means you are excluding this 1. So basically, whatever was the sum here, if this sum was 30, from that you do a -1, -1, -1, -1. You can consider this group as a 0 added here. Okay, this 0 is ignored. But basically, from all the 4 elements, you are doing -1. So if this sum was 30 and you are doing -1 4 times, the sum of the next group is going to be 30 minus 4 times -1. That's what. So basically, you can say that the sum of any ith group. Okay, after that, what would happen? Here, 30 minus 4, 26 was the sum of the second group. Okay, this element was not there. Now, what about the third group? In this, what you are doing is you are doing a -2. So you can imagine a imaginary 0 here. So 2 minus 2 is 0. Then 7 minus 2 is 5. 17 minus 2 is 15. Okay, that's what you are doing. So you are doing a -2 to all the 3 elements. So basically you are doing -2 into 3. Okay. There are 3 elements and you are doing a -2 to every element. So basically -6, 20 was the new sum for the next group. Then you do a -5 to all the elements. So 2 times you do -5. So -2 times 5. So -10, 20 minus 10 is 10. So 10 was the sum of the next group. So basically, how would you find this array? Sum of the ith group. You would say that the sum of the ith group is whatever was the sum of the I minus 1th group minus you would do if you were at this group, to go to this group, I did 4 times -1. So 1 was this, if you are calculating for second group, this was the value at A1. 1 was the first value, A1. Okay. So basically you can say this is AI minus 1. How many times would you subtract this? Is the length of the I minus 1th group. Okay. So what is the length of first group is 4. Okay. Length of first group is 4. Length of second group is 3. Likewise. So length of first group is n, you can say. Length of second group is n minus 1. Length of third group is n minus 2. So length of ith group is n minus I plus 1. Okay. So this is the first thing that we derive, is that the sum of any group is sum of the previous group minus ai minus 1 into n minus I minus 1. Okay. If you subtract this from the previous group, you would get the sum of the next group. So like this, in order, you can compute the sum of all the n groups. Okay. Just by going to every I using this way. In order of n, you can compute the sum of every group. Now, in that, if you apply the prefix sum of this group, if you take the prefix sum of that, so after taking the prefix sum of that, you can compute the sum from any range using that prefix sum. Okay. So that sum, this middle range, if you want to compute from L to R, for all the groups that are coming completely, their sum can be calculated like this. Okay. In order of 1, if you take the prefix sum of this, first compute the sum of sum for every group, take the prefix sum of this array, through that prefix sum of that array, my R minus L. That way you can get the sum of complete groups in the middle. Now, how we calculate these partial things? Okay. So what I would say is, if L is belonging to some group I and R is belonging to some group J, then take the complete sum from for all this whole group and subtract this extra thing. That is what I'm doing. Okay. So you know how to take the complete sum till here. You can take the complete sum till here also. So what I'm doing is, first I would compute to which group L is belonging, to which group R is belonging. Now, if L is belonging to group 1, R is belonging to group 3, take the sum from group 1 to group 3 using this prefix sum. Okay, and then to that subtract these extra elements. So how do we compute these extra elements? That's another thing that you need to determine. So how do you, if you are at some ith group, you want to compute the sum of the initial elements. First thing is how many elements are there. So in if you have computed the group number, then first you would determine that okay, let's see. If you are at some group number 1, it has some n elements. Group number 2, group number 2 starts with n plus 1. It has n minus 1 element. So where would it end? It would end at 2n minus 1. Okay. Group number 3, it starts with 2n. It would have n minus 2 elements. So it would end at 3n minus 2. Okay. Group number 4 would start with 3n minus 1 and it would have n minus 3 elements. So it would end at 3n minus 3. Okay. I think, yeah. So that way, these
So
are the range of
you
the
get to
groups.
this part. Can you repeat?
Okay, what I'm telling is my group number 1 has a length of n. So indexing, these are the indexes that I'm writing. From index 1 to index n would be group number 1. From index n plus 1, the second group has n minus 1 elements. So index n plus 1 to 2n minus 1. Okay,
Mm.
so this would be the second group. This would be third group. This would be the fourth group likewise. So now once we know in which group L is belonging. So if we have an L, so what you can do is store these starting points of every group in some array. Okay. So let's say in some vector you store these starting points of every group. Okay, let's say I'm denoting in my code, I've written it as size. So this is 1. Then you add a plus n, that would be next starting point. Then you add a plus n minus 1. Okay, then plus n minus 2. Likewise, if you add, you get these starting points. Okay, store these starting points in the vector. Now whenever you are given an L, you want to compute which group it belongs, you can use an upper bound function or something like that in this to get okay, which is the to which group it is belonging. So if it is in this range, it is belonging to the this is group 1, group 2, group 3. It is belonging to this group. If it is in this range, it is belonging to second group. Okay. So if you take the number just the starting point just less than equal to L, whichever is the starting point just less than equal to L, whatever is the index of that, that is the group number it is belonging. That you can compute using an upper bound function. Okay. So in log n time you can compute. So once you have computed the group number, okay, let's say this L is belonging to group number GL. With GL, I am denoting the group number of L. Okay. So I'm telling that this L belongs to group L, and same way I can compute for R which group it is belonging. This R belongs to, let's say, group number R. Okay. GR is the group number of R. So once I've computed the group number it is belonging to, then I'll compute the sum from group number GL to GR, complete sum. From that, I need to subtract this thing. So from the GL, from that group, if I know the L, then what are the initial? Okay, so if let's say L is at the third group, okay, this is my GL. Okay, L is somewhere at the third group, L is somewhere here, let's say. Okay, so what is the thing that I need to subtract is this. Okay, I have taken this complete group. I need to remove this group, all the things which is coming before L. So what would be this sum? This sum is going to be for any group number 3, it is having the sum. What is group number 3? Group number 3 is having, okay, if we are A1, A2, A3, A4, A5. Let's say I have something like this. Okay, then I computed the prefix sum also. So PR1 is the prefix sum. Okay, with that I'm denoting the prefix sum. Okay, my group number 3 has the prefix sum starting with 3. Okay, this prefix sum. Okay, so the first element is this A3. Second element is A3 plus A4, this element. This third element is A3 plus A4 plus A5. Okay, so first of all, what is this? How do we get this A3, then A3 plus A4, then A3 plus A4 plus A5? Okay, so like A3 plus A4 plus A5, if you look at prefix 5, okay, prefix 5 is storing the sum from here till here. Okay, from that, if you like from that, if you subtract this, you would get A5, like this thing, this third element, sum from A3 to A5. Okay, if you want to get sum from A3 to A4, prefix 4 minus prefix 2 would give you. But one by one, you cannot calculate this. You need to get the sum of this whole thing, sum of A3. Okay, what is this? This is A3. This is A3 plus A4. This is A3 plus A4 plus A5. You need to get this sum. Okay, A3 plus A3 plus A4 plus A3 plus A4 plus 5. So to do that, you would compute the prefix sum of your prefix sum. Okay, what I'm doing is I'm computing another prefix sum of this. So that what is I'm doing is I'm taking the prefix sum of this prefix array. So what I would say is this first index A3 is like this sum, we can say, is this prefix sum. What would it have? PR1, it had A1, PR2 was A1 plus A2, this was A1 plus A2 plus A3. So prefix sum of prefix sum I, let's say I'm doing prefix sum of prefix sum of 5. What it would store? It would store A1 plus A1 plus A2 plus A1 plus A2 plus A3 plus A1 plus A2 plus
Your
A3 plus A4. Yeah.
PR is currently storing the like 30, 26 like that, right? The sum
Uh,
of that, or what is it
PR,
storing the
PR
prefix?
is storing the prefix sum 1, 3, 8, 18. Okay. That group you forget, that I told you to take the complete sum. That is one part. Now I'm trying to calculate for any group what is sum of one parts. Okay. So I'm not counting this here. I'm
Mhm.
talking about this prefix sum. Okay. So this is my array A, and this is the prefix sum of that simple prefix array. Now PPR that I'm telling is the prefix sum of this prefix array. So it means PPR of 5 would store the prefix sum 1 plus prefix sum 2 plus prefix sum 3 plus prefix sum 4 plus prefix sum 5. Where prefix sum 1 is A1, prefix sum 2 is A1 plus A2, prefix sum 3 is this, like this. Okay, this is what PPR 5 is storing. Now what I need to compute is this thing. How can I get this thing from that? Is, you can see, this is actually, if you see from like from my prefix array, my prefix sum 3 to prefix sum 5, if we add these three things, okay, these three things, okay, it has A3, it has A3 plus A4, this thing, and A1 plus A2 is like coming to all of them. Okay, so we can just subtract A1 plus A2 from this thing to get this. So what I would say is this sum is actually PPR of 5 minus PPR of 2. Okay, so this minus this is going to give me this PPR of 2. This is subtracted. Okay, so like this I'm telling is, okay, this thing is actually this whole thing. Okay, so if I want to compute this sum, I would say the prefix of prefix sum 5 minus 2 is going to give me this. From that, I would subtract this A1 plus A2, the length of this times. Okay, so length was 5 minus 2 was, okay, so 3 times. So from this, I
Abhinav,
would
can you write
subtract.
it on a like clean different sheet probably,
Yeah, yeah. Okay.
because it's confusing.
Mhm.
Like,
Yeah, okay. So,
And how do you arrived at 5 and 2 that value for group 3?
okay, that I've, okay, I'll explain more clearly.
Okay.
So, what I needed to compute here was for group 3, okay. So, for group 3, I needed to compute, this was index 2n, which was having A1. Index 2n plus 1 was having A2. Here, sorry, A1 plus A2. Sorry, this was A3. A3 plus A4 and A3 plus A4 plus A5. That's what the sum that we needed to compute. A3, A3 plus A4 and A3 plus A4 plus A5. Okay, then I have L here and then something is there. Okay, so I needed to compute the sum up till this index. So how I'm computing is, okay, this was group 3. So what was here is, so what I'm telling is I have A, which is A1, A2, A3, A4, A5. I computed the prefix sum of A, which was storing A1 and then A1 plus A2, then A1 plus A2 plus A3, like that. Then I took the prefix sum of this prefix sum, which is storing A1 here, then A1 plus A1 plus A2. Okay, that is stored in the second index. Likewise. So what I need to compute is this sum A3 plus A3 plus A4 plus A3 plus A4 plus A5. So to do that, what I'm doing is, okay, you can see it is some sum of this array, some pattern of this is
Yeah,
coming.
multiplicity of different numbers, 3 to 1 in sequence.
Yeah. So what I'm telling is, if you look at PPR5, what was that?
A
That
5, how
was
did you arrive?
because I need to compute till A3 plus A4 plus A5. Okay.
Okay.
So
Hmm.
where would I get this thing till A5? In
Yes.
PPR5, I would get that.
Yes.
Okay. So my PPR5 is A1 plus A1 plus A2 plus A1 plus A2 plus A3 plus A1 plus A2 plus A3 plus A4 plus A1 plus A2 plus A3 plus A4 plus A5. Okay. And what I need to compute is from A3 till A5. Okay. This sum of sums from A3 till A5. So if I take these three values, that's what is needed. So how to remove these two values is, if this was actually PPR2. So if I write PPR5 minus PPR2, this is going to give me this sum.
2 number is coming from previous group value or like,
Yeah, that would come from the X. Like if I'm at group 3, then 3 minus 1. Oh, the group number minus 1 would come here, because if I'm at group 3, I'm starting with A3. If I'm at group 4, I'm starting with A4. Okay.
correct. Yeah.
So what I need to subtract is A2 and A1. Those I would need to subtract. Okay. So if I take this sum, the sum of prefix sums from the range 3 to 5, this is sum of prefix sums from the range 3 to 5. If I subtract PPR2, this is this thing. From this, if we want to get to this, what we need to subtract is, this is A3, this is A3 plus A4, A3 plus A4. This is the thing we need to get, and we need to subtract this thing, and this thing. So what we need to subtract is A1 plus A2 3 times. So basically from this, if we subtract, what was A1 plus A2? It is prefix sum of 2. Okay, a normal prefix sum of 2 is A1 plus A2. That is subtracted how many times? 5 minus 2 times. 5 minus 2 is the number of terms here. Okay, so if we do this, then we would get to the sum this that we need to subtract.
5 minus 2 is the overall thing, or like this final formula is the one in the blue line?
Of 5 minus 3 is the basically you want to compute from 3 to 5. So
Correct.
number of terms coming here. That is what it is. I would write in the terms of variables now. Just to make it clear, I used an example. Okay.
Okay, so you are subtracting how much value it is? Can you go down? Yeah, it is
From
PPR of
this
5 minus PPR of 2 only, or the second term is also there?
PPR of 5 minus PPR of 2 is this much.
Yes.
From that, if we subtract 3 times this much, which is this, then the overall value that we get would be this.
Okay. Okay.
Okay.
Got it.
So this is the thing that we need to subtract from my overall answer. Okay. So basically this, I would say this whole thing that I get is A3 plus A3 plus A4 plus A3 plus A4 plus A5. This is the thing. So just before L, whatever thing is coming. So in group 3, like you can see in what I did initially in my answer, I stored if L was belonging to group 3 and R was belonging to some other group. I did the whole sum from GL to GR, the complete sum. From that, I need to subtract this thing and all the things coming to the right of R. If these two things we subtract, then we would get the sum from L to R. Okay. So how do we subtract this thing? That can be calculated like this. Okay. So how do we write this in terms of variables? This was just one example. So basically what I need to do, if I'm at some group I, okay, let's say, okay, my group number is GL. Okay. So if I'm at some group GL, okay, I'll write in the same variables that I wrote in the code so that you will understand. So as I explained above, GL is the group number to which L is belonging. So if I'm at group number GL, then uh, and in group number GL, L is the index L is somewhere here. Okay, what is the first index like what is the starting index of the group that I would, okay, in my variable, how do we get the starting index? As I explained here, the starting indexes of all the groups is stored in a way, vector size. Okay, so if I'm at a group number GL, so this is, you can see if this is zero based indexed. Okay, so group number 1 is at index 0, group number 2 is at index 1. Okay, so group number GL would be at index GL minus 1. So this index would be size of GL minus 1. Okay, this is the starting index of my group GL. Okay, starting index of group GL is this, and L is the index. Okay, L is the index from where my sum is starting. So I need to subtract this value. Okay, so what would be this value that I need to subtract? That would be equal to, what I'm doing is prefix sum. What I did here is uh, PPR 5 minus PPR 2. What was that actually? PPR 5 was actually this here. If you see, if my starting index is, if I'm at group GL, I'm starting with A of GL. This is the first element of the group. Okay, for every group, the first element is, for group number 1, the first element was A1, group number 2, first element was A2, group number GL, first element would be A of GL. From that, I am summing up till, okay, uh, what is this before L minus 1? I would say this index is basically, if this is, okay, whatever was the sum till here, the sum of sizes before that. Okay, if you subtract that from L, okay, so from L, I would subtract, from L, I would subtract all the, how many are coming here. So if this index is size of this, number of index is this minus 1. Okay, so basically this index I can say is L minus, you would say, Okay, this index is L minus 1. Okay, if this is L, this index is L minus 1. Okay, leave it like that. So if this is L minus 1, I have to like what would be this? If this is A of GL, this would be A of GL plus 1. Likewise, it would go. Okay, so whatever is the length of this GL plus length of this. So length of this is actually L minus 1. Okay, this length is L minus size of that. L minus size of, okay, that is this length plus GL. So plus GL minus 1. Okay, that's what you would get. Like you can do a plus 1 minus 1 in the variables and compute yourself. So this is the basically what you would get. A of this, okay, is what you would get here. So whatever, let's say this thing is J. So A of J is here. Okay, so you need to take the PPR of J minus PPR of GL minus 1. Okay, so what I did here is if I wanted to compute the sum from A3 plus A3 plus A4 up till A3 plus A4 plus A5. So I'm taking PPR of 5 minus 3, 5 minus 3. So what was that? PPR of this index minus this minus 1. Okay, so PPR of J minus GL minus 1. This is what is going to give me this sum. From that, I would subtract 3 times this. Okay, so what was 3? 3 was 5 minus 2. So what I'm subtracting is the prefix sum of 2. Okay, 2 was this GL minus 1. GL minus 1 was 2. Okay, so I'm subtracting the prefix sum of GL minus 1, and that is coming how many times? This difference, J minus GL minus 1 plus 1 minus 1. Okay, so J minus GL would be the length.
Should be minus, right?
Yeah, J minus GL.
No, this second.
Yeah, minus. Okay, sorry. Here I'm subtracting that. Okay, so this is the thing. This is this sum. Okay, this sum can be written in this in terms of the variables. Okay, so this thing we would subtract from our answer. And also one more thing that we need to subtract is the sum after R. Okay, so for the group number GR, okay, it would again have something like this, where we would have an index R. We need to subtract this sum from that. Okay, so what would be this sum? Again, this sum would be like computing this sum was PPR of, okay, PPR of, if you want to compute for this range, this minus 1. So for this range, it would be this last element is basically, okay, basically the index here, the last element for group GR, the last element would be n minus GR plus 1, because for group 1, it would have n elements. So n minus 1 plus 1 would be n. For group 2, it would have n minus 1 element. For group 3, n minus 3 elements. So this would be the last index. So PPR of, okay, it won't be last index, but it would be PPR n only directly, because like you can see, uh, in group number GR, we would have A of GR, then A of GR plus A of GR plus 1. Like that, we would start, and the last element of the group would be A of GR plus up till A of N. That would be the last, for every last element of the group, it would end with N only, sum till N. Okay, so it would be PPR of N minus PPR of this thing we need to like, this is A of whatever, if I'm telling at the Rth index, we have A of J, then I would subtract PPR of J from that. Okay. If this thing is subtracted, we get this sum. From that, we would have to subtract for this group number, like this thing, the prefix sum of the group number minus 1 times the length. Okay, because in every element we would have, like, this thing would be some sum which would have something like this. Okay, so if it is group number 3, it had A1 plus A2 subtracted from every element. If it is group number GR, it would have the prefix sum up till GR minus 1. Okay, this thing would be subtracted how many times? This length, n minus j times. Okay, so this is also the thing that we need to subtract from our final answer. Okay, so my final answer is going to be, so I can say my final answer is going to be, okay, once we have computed GL and GR, the group number of L and group number of R. So from the prefix group, okay, that I had initially computed to calculate the sum of every group. Okay, as I showed you, this thing, this sum of every group was computed. If you do the prefix sum of this, you would get the prefix sum of this array. From that, you would compute the sum from group GL to GR. Okay, let's say this is GL, this is GR. You need to take this sum. Okay, so if you have the prefix sum of this group array, okay, then I can write that my final answer is, if we have the prefix sum of this group array, that GR minus prefix sum of this group array GL minus 1. Okay, that would be the sum of all the groups from GL to GR. From that, we would subtract this thing. Okay, PPRJ. Okay, from that, we would subtract this thing and this thing. Okay, so if I'm telling this is X and this is Y, then I would say final answer is this, minus X minus Y. Okay, I hope it is clear. So if we have computed these prefix array, prefix of prefix array, group array, prefix sum of group array, all these things, if we have already computed, then this whole thing can be computed in order of 1. And computing this GL and GR would use an upper bound function that would be log n time. So for every query, we are using at max a log n time only. So overall time complexity for pre-computation in order of n, we are doing many times order of n things to pre-compute some of the arrays. And then for every query, I'm taking a log n time. So in n plus q times log n, we are computing the final answer. Okay, I hope this logic is clear to you. So we'll move to the code now. Okay, if we look at the code, so all the things that we need to compute. First, I've taken the input array A. Then this is my prefix array. This is the prefix sum of the prefix array. So first I will compute my prefix array. Prefix I is prefix I minus 1 plus AI. So this way I computed my prefix array. Then the prefix sum of this prefix array. PPRI is PPRI minus 1 plus PRI. So I computed the prefix sum of this prefix array. Okay. Once both of these things are computed, after that, I'll compute the group array, the sum of every group. So I have n groups. The sum of the first group is same as the PPR of n, basically the sum of, so the first group is the prefix I, like prefix array is only the sum first group. What is the first group? The first group is the prefix array only. So the sum of this prefix array is going to be stored in PPR n. Okay, so PPR n is going to store the sum of this prefix array. So for the first group, the sum of first group is PPR n. Now, for the groups ahead, I would say the for the remaining groups, how I'm computing, as I explained you, that group I is group I minus 1 minus AI minus 1 into n minus I plus 1. So group I is group I minus 1 minus AI minus 1 multiplied by n minus I plus 2, like plus 1 plus 2, that you can figure out. Okay, so for the first group, if I want to compute for the first group, I would subtract Okay, yeah. If I'm computing for the second group, the first group is of size n. So for I equal to 2, I needed to subtract n times. So therefore, if I'm writing n minus I plus 2, then I can subtract n times. Okay, for I equal to 2, this would result in n. Okay, so a correction here is this would be n minus I plus 2. Okay, so this is my formula. So this way I'm computing the for every group, what is my sum for every group. Now I need to take the prefix sum of this group. Okay, so I'm just in this vector only, I'm doing a prefix sum, g group I plus equal to group I minus 1. This way I'm just taking the prefix sum of this group. So basically in my code, my uh, the prefix sum of the group that I told is same as GRP. Okay, so this group is only converted to prefix sum of the group here. Okay, so this is done. After that, I need to compute the size of every group, this size array. So basically the initial index of every group. Okay, the size array is storing the initial index of every group. So for the first group, the index is 1. So I would initialize j equal to 1. So for every group, for the ith group, in size, I would push back j. So 1 would be pushed back, then j plus equal to next group size would be n minus I plus 1. So after the first group, when I is 1, n minus 1 plus 1 is n. So we would add a plus n. So next group would be 1 plus n. Okay. After that, I would add a n minus 1. Next group would be uh, 1 plus n minus 1. It would be 2n. Likewise, this would be added to my size vector. The initial index of every group is what my size vector is storing. Okay, all these pre-computations are done. Then I would answer the queries. For every query, I have L and R. Now, to compute the initial to the group number to which L is belonging, I would take the upper bound in my size array. Okay, upper bound L is going to give me the index of the value uh, just greater than L, strictly greater than L. So it would give me it would point to the group just next to the group L is belonging, minus size dot begin. So it would point, okay, so if L is in group 1, it would point to index it would point to just after size dot begin. So the first group, if we subtract size dot begin, we would get 1 as our answer. Okay, in zero based index, we would have to do a minus 1 to get the group number. But since this is giving me a zero based index, so my group 1 is the first group. So for that, it would give a minus 1 would give me
We
a
should
0.
consider the previous one with
Uh,
respect to upper bound, right?
yeah. So if I what I have to get is just less than equal to. So to
Yes.
get just less than equal to, we can do uh, just greater minus 1. So basically, I'm doing upper bound minus size dot begin minus 1. Okay. This thing is giving me the index of the current group number. Now, this
Yes.
index is 0 based. The first group would give for the first group, I would get a 0. So to
Hmm.
convert it into 1 based, I would do a plus 1 again. So
Okay.
basically, these both would cancel out and it would be same as writing this only. Okay. You can just try it for, let's say, you can just try it. What you would get is, let's say you have a size of, in size array, you have 1 starting index of first group. Let's say n is 5. So next would be 6. Next would be 10, like that. So if L is, let's say, 3, it is belonging to the first group. From 1 to 5 is belonging to the first group. So upper bound of 3 is going to point to this. Okay. So upper bound of 3 is going to point to a 6. This minus size dot begin. Okay, this minus size dot begin is pointing to this. It would give me 1. Okay, so it's belonging to group number 1 and I'm getting 1. Okay, so this is okay. I hope it's fine. So this way I got group number for L. Same way I would get the group number for R. Okay, so GL and GR, we got the group number for L and R. After that, as I told you, what would be my answer? Prefix sum of the group GR minus GL minus 1. Okay. group GR minus group GL minus 1. This is my initial answer. From that, I have to subtract this X and Y. How am I calculating this X? Is this PPR J minus GL minus 1. Okay, so what was J here? Okay, so how I'm computing J is, what I'm doing here is, what was my J? Okay, J was this A of this index. So what I'm doing is, currently this L is the index for the overall array. If I convert it to the index of my group, for the group, okay, if this is first, second, third, fourth, like this, then this is L. So for that, I'm considering size of GL minus 1 as 1. It means I would have to subtract this minus 1. Okay, like this from L. So what I'm doing, from L, I'm subtracting this minus 1. Okay, so this minus 1, okay, the index just before that is size of GL minus 1. If we subtract this from L, this L was the index of the overall array. Now this L is the index of this group. Okay, so if L is equal to size of GL minus 1, it would be 1. Okay, so after this, now this L is index of this group. Now what is this J? This J is, okay, so first value is GL. So Lth value would be, GL plus L minus 1. Okay, so L minus 1th value would be GL plus L minus 2. Okay, so this J is actually GL plus L minus 2 after L is converted like this. So once L is converted, now this is L plus GL minus 2. That is what my J is. Okay, so like this thing, like while writing the code only, you imagine and write in terms of variables. It just depends on what variables you are using. So according to you just write the formulas. Okay, if you understand what things you have to subtract, so just imagine the variables and find the formula for that, or just write it in like write the values in some paper, some example, through that you just derive the formula. Okay, I hope this is clear how we got this J. So PPR of J minus PPR of GL minus 1. Okay, so you got this thing. From that, we would subtract prefix of GL minus 1 multiplied by prefix of GL minus 1 multiplied by L minus 1. Like J minus GL was basically what we had to multiply here was this length. Okay, so once L is converted to indexing of the group, so the number of elements still here is L minus 1. Okay, so this J minus GL is equivalent to L minus 1. So this length was L minus 1. Okay, so this is what we subtracted from our answer. Now we need to subtract this Y. What would
For
be?
the R part, we could just take the previous group, uh, the partial group, and use the similar formula that we compute.
Yeah, you can do. You like you would not have to calculate another formula. Is what you
Yeah.
can do is instead.
Just take previous group which is
Yeah.
complete and use the partial formula of L to add it to the answer instead.
Yeah. You can do that in the initial sum. Instead of taking from GR to GL minus 1, take it from GR minus 1 only. And then instead of subtracting this, add to the answer this formula
This part,
using
yeah,
R. Yes, you
correct.
can do that. Okay, so that was one way. And what I did here is I'm subtracting this thing. Okay, so this thing is PPRN minus PPR of this J. What was J here? Is J is basically this index R when it is converted to indexing of the group. Okay, initially this R is indexing of the whole array B. When we convert this in a similar fashion, how we converted here, if we convert this R in the same way into the index of the group, then this J is basically this index. Okay, so at index 1 we have GR, so at index R we would have R plus GR minus 1. Okay, so this J is actually R plus GR minus 1. Okay, so PPR n minus PPR j, this we got. Okay, after this minus prefix sum of GR minus 1 into the length, prefix sum of GR minus 1 into this length. What was this length? I've written n minus j here. Okay, so it's actually same, n minus this j. Okay, so n minus GR minus R plus 1. So n minus GR minus R plus 1. Okay, so this is n minus j only. Okay, so I hope this thing is clear, and then we just see out our answer. So what would be the time complexity of this code if you analyze from the code? This input part is order of n here. This prefix computation is order of n. This again an order of n here. Okay. Then this thing again, this two order of n loops, order of n here, order of n here. Then this size is also running n times, order of n here. So multiple order of n's we have for pre-computation. For every query, this upper bound is taking log n time. This upper bound is also taking log n time. And these are some order of one operations. So overall, this is going in q into log n time. This is q into log n time. Okay, inside we have log n operation q times and plus n, n 1, 2, 3, 4, 5, 6 times n we have around. So like overall time complexity you can say is around 6n plus q into log n, which is well accepted for the given constraints, which n was 3 into 10 to the power 5. So around 6 times n is also fine. 10 to the power 6 only, 10 to the power 6, 10 to the power 7. Q is around uh, 3 into 10 to the power 5 multiplied by log n is approx 30. So this is also fine. Okay. So this time complexity is accepted. My space complexity is going to be, we are using some n-sized vectors, many n-sized vectors, A1, 2, 3, 4, 5, 6. Okay, 5, 6 n-sized vectors and remaining are the same thing. So it's order of n only. Okay. So I hope this problem is clear to everyone. If you still have any doubt, you can ask, or I hope you can maybe rewatch the video if you have some doubt in any part. So thank you so much for joining in. Goodbye. Yeah,
Just
yeah,
few
yeah.
simple doubts, like without recording also it would work.
Okay, okay. You can ask. No problem.
Yeah. Firstly, is that this prefix, is this some standard? I just saw it for first time and found it cool. So like,
Yeah, for that, what I would say is like I have also maybe used it for first time only, or maybe somewhere I've used, but that was intuitive only, looking at the basically you can see the thing that we had to compute.
mhm,
If you just analyze what we had to compute, initially only already this array B, if you see this array B, this was already a prefix sum array. This was computed of some prefix sum, prefix sum, prefix sum. In that we needed to find the sum of a range. So
mhm,
whenever we need to find the sum of a range, so that sum was actually of the form sum of prefix sum only. So
mhm,
this thing was going to be used anyways, like just by looking at what is the thing that you need to calculate. From that you
mhm,
can get a little feeling of that. So that feeling like I got initially only, but for every part deriving these formulas and all, this was a little complicated part. So that you have also you have to do a little carefully only, because they like at first time there was a few small mistakes in the formulas which I had to debug, and then it got accepted. So yeah, those things you have to do carefully. And yeah, that sum of prefix sum was from looking at this only, like this was
mhm,
already a prefix sum array, and in that you had to calculate sum of a range.
mhm, mhm. Yeah, like that multiplicity of elements, like A1 is getting repeated 1 times, 2 times A2, 3 times A3,
Yeah.
sorry, reverse. So that came from prefix of prefix. That was good.
Yeah.
Another thing was like it's on not on the PCD thing, but apart
Okay.
from that,
Okay, I
uh,
think I can stop the recording now, then you can ask. Okay. Okay. Thanks for joining in. Yeah, I can stop the recording.